If you see this kind of question, never you multiply the factors out. See an equation like x plus 1 in bracket, x plus 2 in bracket, x plus 3 in bracket, x plus 4 in bracket to be equal to 24 on a test or an examination. Expanding it normally will completely ruin your time. Always look closer at this number because there will be a hidden symmetry that will let you skip 90% of the algebra. Let me show you step by step. Now, x plus 1 in bracket, x plus 2 in bracket, x plus 3 in bracket, x plus 4 in bracket will equal to 24. The first thing we notice here is that the coefficient of x in each of the brackets are the same. Now, let's look at the constants. We have 1, we have 2, we have 3, we have 4. The first thing we are going to do is to find the symmetric center of the constant terms. How do we do that? We simply look for the average of the constant term. We have 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Everything over 4. So we have 1 plus 2, 3 plus 2, 6 plus 4, 10 over 4. And that gives us 2.5. 2.5. Next thing we are going to do, the next thing we are going to do is to shift our variable so that it is centered exactly at 2.5. And how do we do that? How do we do that? We say let u be equal to x plus 2.5. Let u be equal to x plus 2.5. Now look at our first equation. We have x plus 1. X plus 1. Now from u is equal to x plus 2.5. X is equal to 2.5 minus u. That is, x is equal to u minus 2.5. Now let's come back to the first equation. We have x plus 1. Don't forget x plus 1, x plus 2, x plus 3, and x plus 4. So let's take x plus 1. We're going to rewrite this equation using u. We are going to write this equation using u. This is, remember x is u minus 2.5. So our u minus 2.5, then plus 1, which eventually gives us u minus 1.5. Let's take the next one, x plus 2. We have u minus 2.5. Remember this evaluation. X is u minus 2.5. Then plus 2. So we have u minus 0.5. X plus 3. We have u minus 2.5 plus 3. That gives us u plus 0.5. Then x plus 4. We have u minus 2.5. Then plus 4. That gives u plus 1.5. The next thing, we're going to substitute u into the original equation. Note, x plus 1 is u minus 0.5. So I'll have u minus 0, u minus 1.5, sorry, u minus 1.5. Then x plus 2 is u minus 0.5. X plus 3, u plus 0.5. X plus 4, u plus 1.5. Everything is equal to 24. Remember, everything is equal to 24 from the original equation. Now, what do you notice? What do you notice? Note, note, a squared minus b squared is a plus b, a minus b, difference of two squares, difference of two squared. A plus b is here, a minus b is here, so bring them together. U minus 1.5, u plus 1.5, then a minus b, a plus b, u minus 0.5, u plus 0.5 is equal to 24. Is equal to 24. Now, the next thing I'm going to do, let me change all the decimals to fractions. Let me change all the decimals to fractions. So u minus 3 over 2, u plus 3 over 2, u minus 1 over 2, u plus 1 over 2 is equal to 24. Now, these two are difference of two squares. So also this other two, those other two. So we can now bring the difference of two squares together. We bring the difference of two squares together. So we have u squared minus 3 times 3, 9 over 4. Then u squared minus 1/4. Everything is equal to 24. So the next thing we are going to do is to expand the quadratic expression. U squared times u squared is u raised to the power of 4. U squared times minus 4 minus 1/4 u squared minus 9/4 times u squared minus 9/4 u squared plus 9/4 times minus 9/4 times minus 1/4. We have 9/16. Everything to be equal to 24. So u squared minus 1/4 u squared minus 9/4 u squared gives us minus 10/4 u squared plus 9/16 to be equal to 24. Now we can eliminate the denominators. How? We multiply through by the LCM, which is 16 in this case. Multiply through by LCM, which is 16. So 16 times u squared is 16u squared minus 16 times minus 10/4. So sorry. Here is not u squared. Here should be u raised to the power of 4. So we have u raised to the power of 4, u raised to the power of 4. So 16 times minus 10/4 u squared. We have 40u squared plus 16 times 9/16 is 9. 16 times 24 is 384. Now we have 16u squared minus 40. What am I saying u squared? So sorry. 16u raised to the power 4 minus 40u squared plus 9 minus 384 is equal to 0. So 16u raised to the power of 4 minus 40u squared minus plus 9 minus 384 is minus 375 to be equal to 0. Now, what is the next thing we are going to do? We want to factorize this equation. 16u raised to the power of 4 minus 40u raised to the power of 2 minus 75 is equal to 0. If we multiply 16 by minus 375, we have minus 6,000. Then here minus 40. So we think of two numbers. The product will be minus 6,000 and the sum will be minus 40. Minus 140 and 60. Minus 160. Minus 100 times 60 is minus 6,000. Minus 100 plus 60 is minus 40. So those are the factors. So we now have 16u raised to the power of 4 minus 100u squared plus 60u squared minus 375 to be equal to 0. We now look at this side and this side. Something is common. 4, bring it out. U squared is also common. So I have 4u squared minus 25 plus, looking at this other side, 15 is common. 4u squared minus 25 is equal to 0. So 4u squared plus 15, 4u squared minus 25 is equal to 0. 4u squared plus 15 is equal to 0, or 4u squared minus 25 is equal to 0. So 4u squared is equal to minus 15. U squared is equal to minus 15 over 4. So u will now be plus or minus the square root of minus 15 over 4. U is equal to plus or minus. Now, we cannot get the square root of a negative sign, so we have the complex number I root 15 over the square root of 4 is 2. So plus or minus I root 15 over 2. So that is one of the one of the values of u. So or 4u squared is equal to 25 when I move it to the other side of the equation. So u squared is equal to 25 over 4. So u will now be plus or minus the square root of 25 over 4. So u will now be equal to plus or minus 5 over 2. Now, now, remember the equation never gave us u. Remember, we said let x be equal to u minus 1.5. Let me confirm. x is u minus 2.5, sorry. So x is u minus 2.5, not 1.5. U minus 2.5. Now, I now get the value of x. You know, we have our real roots. Here is our real root, and here is the complex root. Plus or minus I root 15 over 2 is the complex root. Plus or minus 5 over 2 is the real root. So now, let's now get the value of x. So, for the real roots, x is equal to plus or minus 5 over 2 minus 2.5. So x will be minus 5 over 2 minus 5 over 2. I've changed this to a fraction, or 5 over 2 minus 5 over 2. So x will be excuse me, minus 5 over 2 minus 5 over 2 is equal to minus 5, or 5 over 2 minus 5 over 2 is equal to 0. So this one gives us minus 5 and this one gives us 0. Now let's come to the complex root. For the complex root, remember, for the complex root, u is equal to plus or minus I root 15 over 2. U is equal to plus or minus I root 15 over 2. And x is equal to u minus 5 over 2. So we have x is equal to plus or minus I root 15 over 2 minus 5 over 2. So this one is simply x is equal to minus 5 over 2 minus I root 15 over 2, or minus 5 over 2 plus I root 15 over 2. So we have gotten the values of x. So x is equal to minus 5, or x is equal to 0, or x is equal to minus 5 over 2 minus I root 15 over 2 or x is equal to minus 5 over 2 plus I root 15 over 2. Please like and subscribe to our channel.